Welcome to Easy Learning, a simple way to understand statistics. Part 1, Contents of this video. The science or branch of mathematics that deals with group analysis, collection, presentation, analysis and interpretation of numerical facts or data is called statistics. When statistical principles are correctly applied, statistical analyses tend to produce accurate results. We come across a lot of information related to cricket batting or bowling averages, profits of a company, temperatures of cities, expenditures in various sectors, polling results and so on. These are in the form of facts, numerical figures, tables, graphs, etc. provided by newspapers, televisions, magazines and other means of communications. The best familiar example is audience poll during game show. These facts or figures, which are numerical or otherwise, collected with a definite purpose are called data. Example of data. Marks obtained by 25 students in mathematics, out of 30 marks. Each number in the data is called as score. Now we can understand collection of data. Data can be collected in two ways. Collection of data. If the information is collected by the investigator itself with a definite objective in mind, then the data is called primary data. Example of primary data, the number of members in each family of a certain colony. The investigator will have to go to each and every family and record the number of members in the family. In some situation due to lack of time and resources, the investigator uses the data already collected by other agencies or official data published or available. Then the data is called secondary data. Example of secondary data: the performance of a school in board examination for last 10 years. The investigator just have to go to the school office and get the required information from the school records. Now, how to present the data in a form which is meaningful, easy to understand and giving main features at a glance. Let us now understand the ways of presenting the data. Presentation of data. Array form. Ascending. Descending. Tabulated. Ungrouped. Grouped. Inclusive. Exclusive. Diagrammatic. Pie diagram. Graphical. Bar graph. Simple. Joint. Subdivided. Percentage. Histogram. Frequency polygon. Example, ascending or descending order. The data shows the marks obtained by 10 students in mathematics, out of 30 marks. 27, 9, 12, 21, 27, 23, 21, 24, 13, 29. The ascending order, increasing order, of the given data. 9, 12, 13, 21, 21, 23, 24, 27, 27, 29. The descending order, decreasing order, of the given data. 29, 27, 27, 24, 23, 21, 21, 13, 12, 9. From this type of arrangement of the data we can easily find the highest score, lowest score, range of data. That is, difference between the highest score and the lowest score, number of students scoring a particular score, number of students scoring less than a particular score or more than a particular score, etc. Let us consider another example. Marks obtained by 50 students in mathematics, out of 10 marks. Here, writing in array form, ascending, descending order, will be tedious as the number of observations is large. Let us learn the tabular form which presents the data in simplified and condensed form, enabling important features at a glance. Here, the range of data equals highest score minus lowest score, equals 9 minus 2, equals 7. A table with 3 columns is drawn. The first column is for scores. Here, the marks arranged in ascending order, second for tally marks and third for frequency. Here, number of students. Beginning with the lowest score, that is, 2, in the data, scores are written serially up to the highest score, that is, 9. Tallies are usually marked in bunches of 5. The first 4 tallies are marked vertically and the 5th diagonally across the earlier 4. A tally of 7 will appear this way on completion. Now, let us go through the list of scores. The first score in the list is 8, so a tally mark is put against 8 in the second column and so on. 9, 2, 5, 7, 3, 6, 4, 5, 9, 4, 4, 6, 5, 4, 5, 7, 8, 4. The 5th tally is diagonally marked across the earlier ones. 8, 2, 8, 6, 8, 9, 8, 7. Similarly for the remaining scores. To get frequency, that is, the third column, we just have to count the tally marks. Here, 4 indicates that 4 students have scored 2 marks. Similarly, we get the frequency of other scores. The sum of frequencies gives the total number of scores in the data. We use the Greek letter sigma for summation. We have not grouped the scores, that is, marks obtained by students, in making this frequency distribution table, so it is called an ungrouped frequency distribution table. Let us consider the next example. During tree plantation drive, 50 schools planted 100 plants each. After 1 year, the number of plants that survived were recorded as follows. Scores in the above data are from 21 to 98. In this case, the ungrouped frequency table would be too long, so we group the scores. We condense the data into groups like 21 to 30, written as 21-30, 31 to 40, etc. up to 91 to 100, as our data is from 21 to 98. Note, we can make more groups of shorter size or fewer groups of larger size, as there is no hard and fast rule about this except that the groups should not overlap. In my opinion, 5 to 10 groups is the proper choice, which include the entire data. These groups are called classes or class intervals. In each of these classes, the smallest number is called the lower class limit and the greatest number is called the upper class limit. For example, in class 21-30, 21 is the lower class limit and 30 is the upper class limit. The class width or class size is the difference between any 2 consecutive upper class limits, or lower class limits. That is, 40 minus 30 or 31 minus 21 equals 10. The average of the lower class limit and the upper class limit of a class is called the class mark or the mid-value of that class. That is, the class mark of the class 21 to 30 is 21 plus 30, divided by 2 equals 25.5. Note. The difference between 2 consecutive class marks is also the class width. That is, 35.5 minus 25.5 equals 10. Let us continue with our example. The first score in the list is 65, which belongs to the class 61 to 70. We mark a tally in the class 61 to 70. Next is 29. We mark a tally in the class 21 to 30. We proceed for the remaining scores in the similar way. The tallies corresponding to each class gives the number of scores in that class, that is, the frequency of that class. The sum of frequencies gives the total number of scores in the data. We have grouped the scores, that is, plants survived, in making this frequency distribution table, so it is called an ungrouped frequency distribution table. Let us consider the next example. The weights of 50 students in KG were recorded as follows. Scores in the above data are from 32.1 to 62.5. In this case, if we condense the data into classes 31 to 35, 36 to 40, etc. up to 61 to 65 as we have done in the previous example, then the scores 35.8, 45.5, 40.6, etc. cannot be included in any of the classes as there is a gap between classes. Here, the scores are in decimal form, so we require continuous classes. The simple method is to select the classes in such a way that the classes are continuous. That is, upper limit of a class and lower limit of subsequent class is same. We can select the classes as 30 to 35, 35 to 40, etc. up to 60 to 65 so that the scores 35.8, 45.5, 40.6, etc. can be included in this frequency distribution table as there is no gap between classes. The classes having a gap are called discrete classes, also called as inclusive form, and the classes without gap is called continuous classes, also called as exclusive form. Now, another problem crops up because the score 45.0 appears in both the classes 40 to 45 and 45 to 50. By convention, we consider 45.0 in the class 45 to 50 and not in the class 40 to 45, and 35.0 in the class 35 to 40 and not in the class 30 to 35. Similarly, 40 is considered in the class 40 to 45 and not in the class 35 to 40. In case of continuous classes, the upper limit is called as true upper limit and lower limit is called as true lower limit of the class. Therefore, we say the true upper limit value, instead of upper limit value, is excluded from each class. Since the true upper limit is excluded from this type of frequency distribution, it is also called as exclusive form method. The first class interval, that is, 30 to 35, can have all values between 30 and 35 including 30 but excluding 35, and similarly for all other classes. Note, here, the class width or class size can also be calculated as the difference between true upper class limit and true lower class limit of any class. That is, 35 minus 30. Or 40 minus 35 equals 5. Let us continue with our example. The first score is 41.7, which belongs to the class 40 to 45. Similarly for other values up to 43.8. The next score is 45.0, which belongs to the class 45 to 50 and not 40 to 45, and in this way for the remaining scores. Finally, we add up the frequencies to get the total as 50. Types of grouped frequency distribution table: discrete classes, inclusive form method, continuous classes, exclusive form method. In discrete classes or inclusive form method, the upper limit as well as lower limit of each class is included, whereas in continuous classes or exclusive form method, the upper limit of each class is excluded and the lower limit is included. Let us learn to convert discrete classes, inclusive form method, to continuous classes, exclusive form method, without altering class marks and class width, as we will require it for cumulative frequency and also while making histograms, frequency polygons etc., which can be drawn only using continuous classes. Discrete to continuous classes. Here the classes are discrete, that is, there is a gap between the upper and lower limits of the consecutive classes. We will remove this gap so that the classes are continuous, that is, upper limit of the class and the lower limit of its succeeding class are same. For this, we find the difference between the upper limit of any class and the lower limit of its succeeding class, that is, the gap. We then divide this difference into two equal parts and add one part to each of the upper limits and subtract one part from each of the lower limits. Let us consider the classes 21 to 30 and 31 to 40. The lower limit of class 31 to 40 is 31 and the upper limit of class 21 to 30 is 30. The difference is 31 minus 30 equals 1. Dividing this difference into two equal parts. That is, 1 divided by 2 equals 0.5. Adding this 0.5 to each of the upper limits and subtracting 0.5 from each of the lower limits, we get the class intervals as 20.5 to 30.5. 30.5 to 40.5, 40.5 to 50.5, 50.5 to 60.5, 60.5 to 70.5, 70.5 to 80.5, 80.5 to 90.5, 90.5 to 100.5. The true upper limit value of each class is excluded from that class. The average of the lower class limit and the upper class limit of a class is called the class mark or the mid-value of that class. That is, the class mark of the class 21 to 30 is 21 plus 30 divided by 2 equals 25.5. Similarly, for other classes, the class width or class minus size is the difference between any two consecutive upper class limits, or lower class limits. That is, 40 minus 30 or 31 minus 21 equals 10. Also, the class width or class size is the difference between any two consecutive class mark. That is, 35.5 minus 25.5 equals 10. In continuous classes, the method for calculating class marks and class width remains the same. Here, class width can also be calculated as, through upper limit minus through lower limit, of any class. We have converted discrete classes to continuous classes without altering the class marks and class width. Let us now learn about cumulative frequency, CF. Considering the grouped frequency distribution table of our previous example, let us answer these questions. How many students have weight less than 35 kg? We get the answer directly from the table, that is, 7. How many students have weight less than 40? Here the number of students whose weight is less than 40 kg include the number of students who have weight from 30 to 35 as well as the number of students who have weight from 35 to 40. So, the total number of students with weight less than 40 kg is 7 plus 7 equals 14. We say that the cumulative frequency of class 35 to 40 is 14. Similarly, we can compute the cumulative frequencies of the other classes. That is, the number of students with weight less than 45 kg, less than 50 kg, etc. And up to less than 65 kg. This distribution is called the cumulative frequency distribution of the less than type. Cumulative frequency, less than type. Continuous classes are considered for cumulative frequency, so the true upper limit is excluded from each class. 7 plus 7 equals 14. 14 plus 21 equals 35. Similarly, for other classes. The cumulative frequency for the last class, that is, 60 to 65, is the total number of scores, that is, 50. This distribution is called the cumulative frequency distribution of the less than, the upper class limit, type. Meaning of cumulative frequency. Less than type. The cumulative frequency 7 for the first class, that is, 30-35, mean. Weights of 7 students are less than 35 kg. The cumulative frequency 14 for the second class, that is, 35-40, mean. Weights of 14 students are less than 40 kg. Similarly, for other classes. Let us now learn about cumulative frequency distribution of the more than, the lower class limit, type. As we have done for less than type cumulative frequency, we can also make the table for number of students with weights, more than or equal to 30 kg, more than or equal to 35 kg, etc. up to more than or equal to 60 kg. From the frequency distribution table, we observe that all the 50 students are having weight more than or equal to 30 kg. Since there are 7 students in the class interval 30 to 35, this means that there are 50 minus 7 equals 43 students having weight more than or equal to 35 kg. Continuing in the same manner, we get the number of students having weight 40 or above as 43 minus 7 equals 36, number of students having weight 45 or above as 36 minus 21 equals 15, and so on. The true lower limit is included in each class. 50. 50 minus 7 equals 43. 43 minus 7 equals 36. 36 minus 21 equals 15. Similarly, for other classes. The cumulative frequency for the last class, that is, 60 to 65, is its frequency, that is, 3. This distribution is called the cumulative frequency distribution of the more than, the lower class limit, type. Meaning of cumulative frequency. More than type. The cumulative frequency 50 for the first class, that is, 30 to 35, mean. Weights of 50 students are 30 kg or more than 30 kg. The cumulative frequency 43 for the second class, that is, 35 to 40, mean. Weights of 43 students are 35 kg or more than 35 kg. Similarly, for other classes. Let us now learn about measure of central tendency. We can make out some important features of the data by considering only certain representatives of it, skipping the study of full data. This is possible by using measure of central tendency. A measure of central tendency is a single value that attempts to describe a set of data. The mean or arithmetic mean, often called the average, is the measure of central tendency that you are most familiar with, but there are others, such as the median and the mode. Mean, median and mode are all valid measures of central tendency, but under different conditions, which we can discuss at the end, after understanding all the three. Let us first learn about mean. Mean, the sum of the values of all the observations divided by the total number of observations, is called the mean of all observations in the given data. Mean x bar equals sum of all the observations divided by total number of observations. It is denoted by the symbol x bar. Let us consider an example. Find the mean of 10, 90, 20, 80, 30 and 70. To simplify our working of finding the mean, let us use the variable xi to denote the ith observation. So, our first observation is x1 equals 10. Similarly, x2 equals 90, x3 equals 20, x4 equals 80, x5 equals 30 and x6 equals 70. Here, number of observations equals 6. Sum of the observations equals x1 plus x2 plus x3 plus x4 plus x5 plus x6. Equals 10 plus 90 plus 20 plus 80 plus 30 plus 70. Equals 300. Mean x bar equals sum of all the observations divided by total number of observations. Equals 300 divided by 6. Therefore mean x bar equals 50. So, the mean of the observations is 50. If the number of observations is higher, then we use sigma instead of writing x1 plus x2 plus x3 plus etc. up to xn, where is the number of observations. That is, mean x bar equals the sum of xi, as I varies from 1 to n, divided by n, where n is the number of observations. Let us consider an example. Find the mean of. Here, number of observations, n, equals 25, the sum of xi as I varies from 1 to 25 equals 575. Mean x bar equals the sum of xi as I varies from 1 to n divided by n. Equals the sum of xi as I varies from 1 to 25 divided by 25. Equals 575 divided by 25. Equals 23. Thus, mean x bar equals 23. Let us now learn to find mean from ungrouped frequency distribution table. For this, we can consider the ungrouped frequency distribution table obtained from the earlier example. We got the frequency distribution table as follows. The table shows that 4 students obtained 2 marks, 2 students obtained 3 marks and so on. Therefore, the total marks equals 4 times 2, plus 2 times 3, plus 7 times 4, plus 6 times 5, plus 7 times 6, plus 8 times 7, plus 9 times 8, plus 7 times 9. Equals f1 x1 plus f2 x2 plus f3 x3 plus etc. up to plus f8 x8, where fi is the frequency of ith entry in the table. In brief, we write it as the sum of fi xi as I varies from 1 to 8. This can be easily calculated by including one more column, that is, fi xi. The values for third column, that is, fi xi, are calculated as follows. For first row, f1 x1 equals 4 times 2 equals 8, and similarly for other rows. Adding the values in the third column we get the sum of fi xi as I varies from 1 to 8. We get the sum of fi xi as I varies from 1 to 8 equals 305. The value obtained by adding the frequencies in second column is the total number of students represented by the sum of fi as I varies from 1 to 8. We get the sum of fi as I varies from 1 to 8 equals 50. Sum of all the observations equals the sum of fi xi as I varies from 1 to 8 equals 305. Total number of observations equals the sum of fi as I varies from 1 to 8 equals 50. Now, mean x bar equals the sum of fi xi as I varies from 1 to 8 if divided by the sum of fi as I varies from 1 to 8 equals 305 divided by 50. Working column. 305 divided by 50. 50 times 6 equals 300. 305 minus 300 equals 5. 0 and decimal point. 50 times 1 equals 50. 50 minus 50 equals 0. Equals 6.1. Therefore, the mean of marks obtained is 6.1 marks. Let us now learn about the next one, that is, median. Median. The median is that score in the data, which has equal number of scores above it and below it. That is, the median represents the middle score, or we can say that median divides the data into exactly two parts. To calculate the median of ungrouped data, it is first arranged in array form, that is, ascending or descending order. Then, depending upon the number of observations, n, the following methods are used. First, when the number of observations, n, is odd, then median is the value of n plus 1 upon 2 8th observation. Second, when the number of observations, n, is even, then median is the mean of n upon 2 8th and the n upon 2 plus 1 8th observations. Let us understand this with some examples. First example, n is odd. Find the median of 72, 92, 78, 54, 66, 63, 87. Arranging the scores in ascending order, we get 54, 63, 66, 72, 78, 87, 92. There are 7 terms, that is, n equals 7. Therefore, median is n plus 1 upon 2 8th term equals 7 plus 1 upon 2 8th term equals 4th term, which is 72. So, the median is 72. Second example, n is even. Find the median of 30, 25, 32, 23, 42, 36, 40, 33, 21, 43. Arranging the scores in ascending order, we get 21, 23, 25, 30, 32, 33, 36, 40, 42, 43. There are 10 terms, that is, n equals 10. Therefore, median is the mean of the n upon 2 8th and the n upon 2 plus 1 8th terms. That is, the mean of the 10 upon 2 8th and the 10 upon 2 plus 1 8th terms. That is, the mean of the 5th and 6th terms. That is, the mean of 32 and 33, equals 32 plus 33 divided by 2, equals 65 divided by 2, equals 32.5. Therefore, the median is 32.5. Let us now learn to find median from ungrouped frequency distribution table. For this, we can consider the ungrouped frequency distribution table obtained from the earlier example. Marks obtained by 50 students in mathematics. Out of 10 marks, find the median of marks obtained. We got the frequency distribution table as follows. We can include one more column here, that is, cumulative frequency. Let us understand the meaning of cumulative frequency obtained from ungrouped frequency distribution table. Meaning of cumulative frequency obtained from ungrouped frequency distribution table. The cumulative frequency 4 corresponding to 2-mark mean. The first, second, third, and fourth score is 2. The cumulative frequency 6 corresponding to 3-mark mean. The next score up to 6th score is 3. That is, 5th and 6th score is 3. Similarly, for other classes, the next score up to 13th score is 4, that is, 7th to 13th score is 4. 14th to 19th score is 5. 20th to 26th score is 6. 27th to 34th score is 7. 35th to 43rd score is 8. 44th to 50th score is 9. Let us continue with our example of finding median. Here, n equals 50, which is even. Therefore, median is the mean of the n upon 2 8th and the n upon 2 plus 1 8th terms. That is, the mean of the 50 upon 2 8th and the 50 upon 2 plus 1 8th terms. That is, the mean of the 25th and 26th terms. That is, the mean of 6 and 6. Therefore, the median is 6 marks. Let us now learn about the last one, that is, mode. Mode. The mode is that value of the observation which occur more frequently, or we can say, that score which is repeated maximum number of times in the given data. That is, an observation with the maximum frequency is called the mode. Let us understand this with some examples. Example 1. Find the mode of 2, 9, 5, 2, 4, 3, 9, 7, 1, 9. Arranging the scores in ascending order, we get 1, 2, 2, 3, 4, 5, 7, 9, 9, 9. Here, 9 occurs more frequently, that is, 3 times. So, the mode is 9. Example 2. Find the mode of 7, 6, 5, 8, 2, 8, 1, 4, 3, 9, 7, 8, 6, 7, 5. Arranging the scores in ascending order, we get 1, 2, 3, 4, 5, 5, 6, 6, 7, 7, 7, 8, 8, 8, 9. Here, 7 and 8 occurs more frequently, that is, 3 times. So, the mode is 7 and 8. Let us now find mode from ungrouped frequency distribution table. For this, we can consider the ungrouped frequency distribution table obtained from the earlier example. Marks obtained by 50 students in mathematics. Out of 10 marks, find the mode of marks obtained. We got the frequency distribution table as follows. Here, the frequency of score 8 is maximum, that is, 9 times. So, the mode is 8 marks. Now, let us understand the suitable and valid measure of central tendency under different conditions. We can get it by some examples. Example 1. The percentage of marks scored by a student in class 9 are 41, 58, 55, 80, 53, 72, 63, 48, 77, 73. To find the overall performance of the student, we have to consider the percentage scored in each test. Hence, the suitable measure of central tendency in this example is mean. Example 2. The wages of staff at a factory. The mean salary for these 10 staff is Rs 30.7k. However, this mean value is not the best way to accurately reflect the typical salary of a worker, as most workers have salaries in the Rs 12k to 18k range. The mean is being skewed by the two large salaries. Here, the median is better measure of central tendency, which comes out to be Rs 15.5k. Example 3. In the following table, the information is given about the number of persons and the shoe size. If the manufacturer wants to increase the production of the shoe size which has more demand, then mode is suitable in this case. The ready-made garment and shoe industries make great use of this measure of central tendency. Using the knowledge of mode, these industries decide which size of the product should be produced in large numbers. Continued in part 2. Thanks for watching this video. For more videos on physics, chemistry and mathematics, check my YouTube channel, Easy Learning. Suggestions can be mailed at ag.easylearning@gmail.com.